Hi guys, welcome to Learning Electronics Repair, and the first thing I would like to say to you all is Merry Christmas. I hope you're having a good one. I hope Santa is being kind to you. Yeah, I love Christmas. I absolutely love Christmas. I shouldn't, because I'm a devout atheist. Yeah, I am a devout atheist, so Christmas is really against my religious non-beliefs, but you can't really resist Christmas, yeah. I mean, that's just not an excuse not to enjoy it, if you ask me. Unlike the lack of definitive proof that a creator or deity actually exists, there's definitive proof that Christmas exists, yeah. Just go outside on the 25th of December, yeah. Unless you're somewhere where people don't like to party, but hey, you probably just don't get out enough if you don't see the evidence that Christmas exists, yeah. And I love a party. I love a party. I mean, don't get me wrong about parties, yeah. And just to labour this point, yeah, I don't believe like in ghosts and demons, but I still celebrate Halloween because Halloween exists, yeah. Although there's not enough evidence that the other things exist. So, point taken, yeah. Everybody should enjoy Christmas. Right, now let's get further with this video then, yeah. Comments below, guys. You're gonna do anyway without me inviting you, yeah. Christmas exists. Right, so I have lots of these things. This was recorded before Christmas. They're all on my house now, and I have about 40. I think there's 8 in this set, and I think I have about, I don't know, 5, 6 sets of them, so 40 odd lights. And every year, you know, you'll find something's packed in, it's not working properly. And this year, 2 of them actually don't work, so I've taken the innards out of them, these 2. You can see what happens to this. Water gets inside them, or it did. It did while I was in England. I brought these with me, had them for some years there. But in Gran Canaria, it doesn't, because it doesn't rain. See, that solved that problem as well. But rain still exists, I know. So, I thought we'd have a look. I mean, there can't be much go wrong with these. And then I kind of like noticed something a little bit strange with these. So on the end of them, we have an 8-pin chip. Yeah, I'll get under the microscope in a minute. We have an 8-pin chip on the end. And we have 16 LEDs. Now, you can see they running in sequence down the whole thing, yeah. And I'm going to have to slow this video down in a moment. Let's see if we can actually see what they really are doing, how many steps there are in the sequence, because it looks like an even flow to me. But how does it do that with just 6 pins on the chip? That's what I want to know. I mean, one of them is positive supply. This is the plus 5 volts coming in. This is the, in fact, actually it's plus 5.5 volts, strangely, the power supply for these. This is the 0 volts. So that takes 2 pins. So we've now got 6 pins left to flash all these 16 LEDs. I hope you think that's strange as well, because just to continue with my previous argument, yeah, even if you don't believe it, there's proof there that it exists, yeah. Okay, so let's just figure out how these things actually work, and then I might be able to figure out what's wrong with these 2. Just before I continue, I will point out, and don't get me wrong here, guys, I'm not singling out Christianity here, yeah. I am happy, as a devout atheist, even though it's against my disbeliefs, to celebrate any religious festival going, as long as it involves partying. If it involves voluntary starvation for a month, meh, I just don't see the point, yeah. But if it involves partying, I don't care what religion, I will be there, yeah. So, now we've just clarified that. Let's have a look at this. So, we have an 8-pin chip, yeah. This orangey gunk is actually glue underneath it, which holds it down. I'll show you another one in a minute. You'll see what that is. And you can see that there's quite a lot of corrosion on this thing. Yeah, a lot of corrosion in here. And that may well be the problem. In fact, I'll just, while I'm at it, I will use my probe, because you guys tell me I shouldn't. I should use a something more suitable, yeah. But we can see, firstly, the chip has no markings, and I've looked at a few of them and they have no markings. If we connect to here, this is a positive connection I've measured off a good working one, and we have a connection to pin 1. So pin 1 is power. Ground, I think this goes on to pin 8. It doesn't go on the other pins, yeah. So pin 8 is ground, pin 1 is power. And we don't have a short, we can just check it. No, and it doesn't go to anywhere else. So we have 6 more pins to go to 16 LEDs, and I think the thing to do is to figure out where they all go. Yeah, let's see where they all go. So I can see some tracks going down the board. I'm just going to try and UV torch, see if that shows up any better as well. Well, the UV torch either isn't working or didn't make a difference, but I've actually just moved the little lamps around on here to decrease the illumination, and now we can quite clearly see where the tracks go. So we can see on this side we have 4 tracks going down the side of the board, and I guess they must be going to LEDs. There's nowhere else they can go. I don't think any of the LEDs will be in series because there's only a 5-volt supply and these are white LEDs, so 2 in series would probably require more than 5 volts. But what I do also notice is there are no resistors on here. Yeah, there's no resistors, and some of the LEDs are mounted one way around and some are mounted the other way. You see little plus signs, yeah, and some are quite corroded. So that's what we have. I think the easy way to figure out which LED goes where is probably to draw on a piece of paper effectively the 16 LEDs and then measure from both pins on each one and see what they connect to. Yeah, I think that's the way to go with this. I'll do the first 1 or 2 on video though, so you can see what I'm doing. So this is the first LED, okay, and if we turn it over, positive is the end furthest away from me. We can see because like inside the LED is like the smaller end of it. So the negative end will go to this chip, one would assume. Get a good connection on it. I don't have a good connection. The corrosion on it is not making a good connection. So that goes to pin 7. And the other end, the positive end, goes to pin 6. So on my piece of paper I'll make a note of that and then work my way along. So here we have a picture of our mysterious chip. Pins 1 to 4, 5 to 8, okay, and 6 and 7 were connected. So this is LED 1 and 2, this is from the top of the strip working the way downwards, and we have a plus and minus. So I'll make a note for each LED, the pins it connects to, okay. So we can see on the first one, I hope I get this the right way round, it was a minute ago or 3, this end was 6 and this end was 7. Okay, and I'm going to do that for all 16 LEDs and then get back to you. Guys, it's going well. I'm figuring out, I'm actually understanding how this works. Have you guys figured it out yet? There is only 4 connections running down this, by the way. It's not double-sided, okay? It might look like it is, but it ain't double-sided. There's only 4 wires running down here. There's a clue. And there are 17 LEDs, not 16. I've now numbered them. I've numbered them, I should say. I say them, it's like a local accent. I tried to lose it. Or is it 18 LEDs? Let me go again. There are actually 18 LEDs because there's one at the end. So there's 18 LEDs in the strip, okay? Anyway, this is relevant. I've just noticed this. I'm working my way down. Working my way down. Oh, working me way. I'll have to try and lose this. Well, this is how we spoke. Yeah, I don't care. I don't care. Working my way down, there's one of the LEDs, just reads open. All the way, I'm on ohms range, so it'll read open. And this one, number 9, reads short, or near to short. So we have one faulty LED here, number 9, so I will just remove that. Yeah, you know what's happening here, you know what's coming now, don't you? Okay, because we need to replace it anyway. I've removed the short, yeah, just to be sure I've removed the short. Okay, I've removed the short. So number 9 now is not short. Yeah, is not short. Okay, I'll carry on. I've done that. Just the one shorted LED, which I've disconnected. Another thing I'll just show you, because this is relevant to how it works. I do know how this works now. So if we measure across any of the diodes, doesn't matter which one, we will see a diode junction in both directions, yeah. And it doesn't matter, we can just go to any of them at random. Let's pick 13, unlucky for some. I don't believe in superstition either, by the way. I don't believe in unlucky for 13 and things like that. I don't believe in a lot, do I really? I believe in what the empirical evidence says is correct. And I believe some rather esoteric theories of what is probably correct. Yeah, I believe in science. That's what I believe in. Okay, so let's replace the one that was shorted and let's see if this actually works. And while I'm replacing the one that was shorted, and before we see how this works, if you haven't figured out how it works by then yourself, yeah, I'll show you. Okay, here's the LED with the cut leg, so we'll chop the other one off. Be nice and marked, plus and minus. I have a replacement one here. You guys thinking about how that works, by the way? Have you figured out yet how you can have 4 wires, and there are 4 wires going to 18 LEDs, and yet you can light them all up individually? Have you figured that? I was a bit surprised actually when I found out how it worked. I tried to get my head around kind of how it might work, and I was wrong. Well, actually no. The way I kind of thought it would work, I then figured out it wouldn't be possible. So I'm thinking, well, I thought there were 16 LEDs to start off with, and I thought, well, 4 wires, that's like effectively 16 different binary combinations. But then that wouldn't work, because you'd have to effectively have a situation where like a binary number could light a certain LED up. And you can't, because the whole point of the binary is it's like the combination of digits, bits, yeah, that select the LED, and there's no like registers or anything on here that would actually cause that to happen. So I think you can be fairly self-assured that whoever designed this was a bit clever actually in how they did it. It was one of these things, or it is one of those things that are like kind of like simple but elegant. Yeah, whoever thought this one up. I hope you agree with me. Some of you probably figured it out, I guess. Some of you have probably figured it out. Where is my solder braid? Can't just lay my hand on it. I'll just use some of this stuff for now. It's probably buried under the microscope or something. But hey, it's Christmas, yeah, it's Christmas. Okay, clean the wires. You can see definitely this is single-sided, yeah, there's no pads on this side. Right, let's put our LED in. Positive end goes to there, that's the long leg. Okay. No, it comes from the other side, of course. It's Christmas, guys. Okay, it goes in there like so. bend it over. Yeah, it goes into the gap like so. Nicely made, this thing. I mean, obviously well thought out, I'll give it that. It's just a smart guy who figured out how to do it that I have respect for. Yeah, I have respect for the guy who worked this one out. I'll bet this was like I'll bet this is a 4 AM moment. Yeah, the design of this is definitely a 4 AM moment, and those of you who have 4 AM moments will know exactly what I mean when I say that. Okay guys, so it is Christmas, and I've been saying several times there were 4 wires, but there's actually 5. Yeah, we can see them all on here. 1, 2, 3, 4, 5. We've got power and ground, so that's 7 pins, and if you look, the 8th pin actually isn't used. Pin 4 is not connected to anything. So we have 5 wires, which I corrected through the videos. You saw every time I said 4, I put 5 on the screen. Okay, so when I first thought about this, I was thinking about it last night when I knew we got some of these not working. Is how does that work? I thought there were 16 LEDs, there's 18, yeah. And I thought, okay, well, 1 wire for like 5 volts, and then like all the other ones like acting as a binary sequence counting up to 16. But that wouldn't work actually, and it would actually only give you 15 LEDs, because the sequence of 1 on that, if it was power, and 1 1 1 1 wouldn't light anything up. Yeah, so it wouldn't work. But I'm going to show you now how this actually works. Yeah, and credit to the guy who came up with this one. So here is our chip, yeah, and here is the big reveal of how does it work. Yeah, I've dragged it out as long as I can now. You can carry on with your Christmas celebrations. Yeah, hope some of you, did anybody get it, by the way? Look, positive, negative end of the LEDs, yeah, they light up in sequence, and 7 keeps appearing here. So look, 7 minus 6 plus, 7 plus 5 minus, 7 2, 7 3, 7 3, 7 2, 7 5, 7 6. So 7 6 is obviously the opposite to 7 6, the polarity. Yeah, that's effectively how it works. So that gives us 8 combinations. Okay, now we continue, but now we use 6 as the common pin. So we have 6 5 6 2 6 3 3 3 6, or 6 3 that way, 6 2 6 5. And that actually only gives us another 6 combinations, because we can't use 7. We've already used 7. That's been used all its possible combinations. So we've got 6 more. And then we go to using pin 5. So 5 2, 5 3, 5 3, 5 2 to the polarity. Gives us 4 more, and that gives us 18. That's how it works, yeah. Comments below, guys. 4 AM idea, that one? It's gotta be, yeah. Anybody get it? Yeah, go on, be honest, let us know. Anybody get it? Okay, now I've replaced the LED. Will it work? Well, let's see. I have my power supply there set to 5.5 volts, which is the same as the power pack. Let's put some power on and see what happens. Hey, it's Christmas, guys. It's working. Yeah, look at that. Obviously, it must effectively scan it, so it must go through all the various combinations for the LEDs it wants to light, maybe several times, then switch to a different combination, and that gives us the vision of the movement. Yeah, it must be scanning at quite a high frequency. We'll have to know what this chip is, but for those of you who don't, and I don't, you could do this with an Arduino, couldn't you? Could you? Yeah, I don't mess with those things, but somebody can probably tell me, can we do that with an Arduino? Let's see. Answers below. Okay, well, we could end this video there, but we have one more of these things, yeah. So let's have to see what's wrong with this one, even more corroded. Can we get this one to work? So here is the other one. Very corroded, this one. But we can probably clean some of that off. It's not so bad down this end. It's just the top end really of this one. A little bit bent. And is that one broken? No. Just It's feeling the rust, yeah, it's feeling the strain. Okay, so that's this one. But the problem with this one, I don't think is the LEDs. I mean, it may have LED problems as well. But problem with this one is here. So you see that this pin on here is kind of like vanished. So we kind of have like a 7-pin chip rather than an 8-pin chip, and that one wasn't used. So we're now down to 6. That's what's wrong with this one. The leg's gone. It's off its legs, yeah. Can we fix that? Well, it is Christmas and all that, yeah. Let's have a look. So can I scrape away? I may need to use the optical microscope to do this. I can see a lot better in stereo vision. But yeah, I have a bit of like copper there. Yeah, it's coming cleaner now. So I can probably solder to that, you know, and solder to this. Let's try and clean it up a little bit. I think I'll try and clean up all the soldered joints using flux, solder braid. See what we can do with it. Just because it's Christmas. Okay. This is probably going to be difficult without the optical microscope for me, but let's see. So first of all, I'm just going to come in with some fresh solder. Yes, if I actually clean some of the crap off with the flux. Same on the other side, I'll turn it round. Make life easy. I really should put something on the soldering, on the microscope base. This end's not so bad. More flux. Okay. Try it. Bit of fresh solder. Okay, a bit more. I'll try not to actually unsolder the chip. Okay, so let's clean this up now and see how it looks. Okay, so I've cleaned that up. We can definitely see the copper. So let's see if we can solder a bit of wire to that. A bit of thin wire. And I'll probably just take one end from here and then the other end straight to there, yeah. And let's see if it works. Well, at least I'll scrape some of this away, yeah, you can see it now. So I've got somewhere to attach it because the wire is attached to this. So I'll fit something onto here so it doesn't fall off when I put the wires back on. Okay. Let's see if we can get something to attach to that first. And I'm going to have to do this under the optical microscope. Picture's not as good as this one, guys, but if you want to see me do it and any chance of success, that's the way I'll have to do it. Okay, so we can see we have a little bit of copper there. You can see the metal. That's as much of it as I can get, to be honest. We have a little bit of solder on here where I've tinned it, and I'm going to use a very thin bit of wire. So the first thing I will do is attach the wire to the board, because if I do get it to stick to the chip, I don't want it to be waggling around afterwards while I solder the other end. Okay, so there we are, that's soldered to the board. Now looks like I'll have to cut it a little bit shorter, not a problem. Okay, let me see if I can actually get some solder onto that bit of copper that I can see. I'll balance, I'll use my meter just balanced onto the PCB so it's not waggling around, hopefully. Okay, I have some flux on the chip. You can see where the flux is on there. Put a bit of the solder as well. This is the narrow solder, 0.22, no sorry, 0.2 millimeters. Can I get any onto there? It doesn't look like it wants to tin onto it. I'll move the wire out of the way. Let me come back at it this way with the soldering iron flat. Now I think I have it. Yeah, can you see it? So we have, oops, we have the little bit of a pad tinned. Now we need to come in with this bit of wire and see if I can solder that to the chip. Need to move it a bit further that way. You know where the little bit of copper is? No, I can see it's not there. The little bit is tinned is a little bit further in. Let me tin the end of the wire. Let's tin the end of the wire. Once again. Right, it's down by the chip, and I want to see if I can do this. I'm going to use my left hand, which is not my favourite hand, but I'm not bad with it these days, to hold the wire in place. I need some new tweezers, I've ordered some. Let's see if I can attach it. Nope, try again. I may be better using the tweezers right-handed and the soldering iron left-handed. So we go. Once again, the wire's in place. Okay. Will it just solder? Let's have a go. I think I'll have to push down on it with the tweezers. And do I have it? No. Okay. I'll try it right-handed. Okay, I think I have that in place now. Let's try. Okay. See if we've got it. Well, it's stuck down, so I'm assuming that means it's soldered to the metal. It's not just being held down by the flux. I mean, it may have stuck into the plastic, but I don't think so. So I think that's a pretty good attempt. Let's chop the wire off a bit shorter then. Let's see if this actually works. As you guys like my pieces of paper, let's just show exactly how this works. The LEDs are connected in pairs. So I'll just draw one pair of them and they're like so. Okay, LED. And we'll say this is the first LED in the sequence 1. So you can see LED 1 lights up when pin 6 is positive with respect to pin 7, so 5 volts and ground. Okay, so this is pin 6 on the chip and this is pin 7. We put positive on here, negative on here, and this LED lights up. Now if you look down the sequence, you'll see here LED 8 is the same pins, just the opposite way round. So this one will be LED 8. It's obviously not physically next to LED 1 in the sequence, it's down there somewhere. Okay, but that's how it's wired. So what we do is to light LED 8, we make 6 negative and pin 7 positive. So by switching the polarity, we can light one or the other. And the way this works then, it's running through the sequence of LEDs very fast, hundreds of times a second, I would think. Okay, I've sort of drawn a bit of this out to show exactly how it works. So in the first instance, we want just the first LED to be lit at the top of the icicle thing, yeah? So we put 5 volts on pin 6 and ground on pin 7. And we can do that, say, for 1/10 of a second. Now, in the next step, we want the first LED and the second one to light up. So these are your LEDs. Okay. So to do that, first of all, we need to light this one. Yeah, 6 positive, 7 negative. And then we need to light the next one, which is actually, I've drawn it wrong, it's 7 positive. And it is 5 negative, okay? So we first put this on, plus minus 6 and 7, then we put this on, plus 7 minus 5, and we do this very, very rapidly, say hundreds of times a second. So you will just see both LEDs lit up. The fact that they're actually flashing backwards and forwards is so fast you can't see it. So in the third step, we want that one, we want this, and we want the next LED to light up, which is 2 and 7. So 2 is the positive and 7 is the negative or ground, okay? So in the third step, say each step is 1/10 of a second, yeah? Step 3, we send each of these in sequence very rapidly again. So you just see each one lit up, although they're actually flashing rapidly. And we can do the same thing. We can light up 4 LEDs by sending each of these, and we want the fourth one, which is 7 positive, 3 negative. So we now have 4 LEDs lit up. So the next thing we want to do is turn that one off and have these 3 on and this one on and these off. Okay, so it moves down one. So the sequence is now changed. Now on step 5, we actually have 7 positive, 5 negative, or ground, yeah. We have 2 positive, 7 negative. We have 7 positive, 3 negative. And what's LED 5? 3 positive, 7 negative. So again, we send each one very rapidly, strobing between them all, hundreds, maybe thousands of times a second. And you will now see these 4 LEDs lit up. And you can see, next step, we just sort of go down like so. So on step 6, we want those 3, plus the next one, which is 7 positive, 2 negative. And you see the LED move down again. Yeah, the LEDs just float down the thing. And when we get to the end, we go 4, 3, 2, 1 until they're all out. So that's how it's working. It's just sending groups of codes, if you like. Yeah. If the most LEDs ever lit is, say, 4 of them at a time, then if we do this at 240 times a second, each one has been flashed 60 times a second, and you can't see them. You just see them on as a solid light. Although my cat, Munchito, he can probably see it flickering. And a fly with its 200 frames per second vision can definitely see them flickering. And we get flies here in December, by the way, weather being 24, 25 degrees. Okay, but we don't get water in our Christmas lights. Let's see if we fixed it now. Okay guys, you can see it yourself under this microscope. I think I may have it, but I can't say for certain. Maybe I could measure the resistance from the wire to some of the other pins, like in diode mode. If I see anything, then I know I have it connected. But let's just try this first. Power supply still on 5 volts from the previous time. Okay, we go there. What, does it do anything? Yeah, look at that. Okay, 1 LED out, but I mean that's not a problem to change. 2 of them, yeah. Can change a couple of LEDs. Okay. I hope you enjoyed that video, guys, and also I hope you can see how many skills we can learn by repairing pointless things. Yeah, the only way to learn to do that when it really matters, when you need to do it, is by learning by doing it on these sort of things. Yeah, that's just so obvious. Yeah. Okay, well, I hope you enjoyed it. I hope you're enjoying your Christmas, and believe me, it really does exist. And I'm looking forward to seeing you all soon on another Learn Electronics Repair video. Merry Christmas, guys. Ciao for now.